But I am telling you to observe. Okay, this is a difference between seeing and observing. Now I am going to do something, and I want you to observe the ball the moment you hear the sound tuck. After you hear the sound tuck, you will see the ball, right? And you have to keep observing the ball till once again it comes back and hits the bat. But you are not going to see the bat, right? Ready? Okay. Now, this is the position of the ball. This is the position of the ball. This is the position of the ball when it just left the bat. Now, I want you to give me all the relevant vectors associated with this motion. Right? Now keep telling me, I will keep drawing the vectors. Right? You keep telling me, I will draw. Tell, all of you. I know, but you should tell. You should tell what I should do. I will do that.
Sir.
Yes, louder. And your answer should be louder. Come on, tell.
Directions.
So what I should do? I should draw a velocity vector. Hello?
Yes, sir.
For this, I should draw the velocity vector.
Yes, sir.
So now I am going to draw the velocity vector for this. Okay?
Yes, sir.
Okay. Right. So I will draw the velocity vector for this. Right? Like this. Right? Okay. So did you appreciate the velocity vector?
Yes, sir.
The ball has just left the bat.
Yes, sir.
And it is at position P1. Right?
Yes, sir.
Now the ball is traveling and it will go here.
Yes, sir.
So here also I should draw the ball is still traveling.
Yes, sir.
What is the velocity vector I should draw? So I should draw the velocity vector which is not like this, correct? It should be shorter than this. That's what you are telling, correct? The velocity vector should be shorter than the previous one. Okay? That's precisely what you want me to do, right? Okay. So the velocity vector is shorter than this. I hope you can appreciate.
Yes, sir.
Or still shorter should I draw? It is okay? It is little shorter than that?
Yes, sir. Yes, sir.
Then it reaches the highest point. At highest point, what is the velocity vector I should draw?
Zero.
At highest point, when the ball goes to the highest point, zero. It will just go and stop there.
Yes, sir.
So you will draw no velocity vector there.
Yes, sir.
Okay? Then the body starts. What happens to the ball after reaching the highest point? It will fall down. So will it again come back to this position?
Yes, sir.
So if it come back to this position, if it comes back to this position, right? If it comes back to this position, right? So it will come back to this position, correct?
Yes,
now you
sir.
please understand. Here the position is P1. Here I will call this position as P2, and here I will call this position as P3, right? And here the instant of time when you see the ball here is T1. The instant of time when you see the ball here is T2. And the instant of time when you see the ball here is T3. Okay. Now the ball starts returning. Hello. Will it come back to this position?
Yes, sir.
So when it comes back to this position, what is the instant of time?
T2.
T4.
Who said T2? Why?
Sir,
Why did you say T2?
I saw that T2.
It is going up now. So T1, T2, T3. And then the next instant of time is coming down now. You understood? Why did you say T2?
Sir, I saw that T2.
No. Now see, you have to be with my flow. I am now saying the ball is going up. Then it went up. Now it started falling down. So it will come back to that position. So will it be same time T2? Then it will be the next time instant now. Be careful. All of you think and answer. So it will come back to this position. The instant of time will be T4. And Harshita, you are keeping quiet. I don't like that. So it will be T4, right? Then here should I show some velocity vector?
Yes,
So what is the velocity vector I should show there?
Equal to that.
Equal to that, correct?
Yes,
In
sir.
the same direction, correct? Good. So in the opposite direction I should show the velocity vector. Correct?
Yes, sir.
When it is coming back. So when it is coming back, I will show the velocity vector will be like this. Okay? Okay, I'll show it like this. Okay? Then when it comes here, again I have to show the velocity because again it is coming back to that position. Correct?
Yes,
Now
sir.
what should be the velocity vector here? It went up to its highest point, it came down. So it comes to this position and again it is coming back to this position now.
Yes, sir.
What should the velocity vector be there? It is not at hit the bat, man.
Sir,
Sir,
same
longer
equal
than
chance.
the-
It is not hit the bat, it has left the batter.
Yes, sir.
The bat is below this. So again you will show the same velocity vector.
Yes, sir.
Same, but it will be having the same magnitude like this. Hello, are you with me?
Yes, sir.
And so I am showing this color for this. Okay?
Yes, sir.
So you are shown now the green ones are representing the velocity vectors when the ball is going up, and then the brown ones are representing the velocity vectors when they are coming down. I hope you are observing.
Yes, sir.
So what will be the instant of time when it comes here?
T5.
T5. Got it? The
Yes,
instant
sir.
of time will be T5. Okay? Okay.
Yes, sir.
Now, what are there any other significant vectors that I should show?
Sir,
Love.
acceleration vector and gravitation.
Yes. Acceleration vector and
Gravitation.
what do you mean? Gravitational force and acceleration vector. Okay.
Gravitational force vector.
So you show one of them.
Yes.
So see, now if you show force vector, fine. But consequence of force, if you already know this is the acceleration, then you better show that. See, when you come to this class, oh hello, you with the green shirt, come here, I will call you like that. But if I know your name, I will rather call your name. So here we know what is the acceleration, correct? So when the body is going up, right? So what will be I have to show an acceleration vector. That's what you told. Hello?
Yes,
Yes, sir.
So I will show the acceleration vector, right? So I will show the acceleration vector, right? So for the body which is going up, this is the green is the velocity vector.
Yes, sir.
What will be the acceleration vector? In which direction?
Sir, opposite
Opposite of velocity. That means I should show it in the downward direction.
Yes,
Good.
sir.
So I will show it in the downward direction, right? So this is the acceleration vector at this point. At this point, is there acceleration vector?
Yes,
sir.
What is the magnitude and direction of the acceleration vector there? What is the magnitude and direction of the acceleration vector here? Think and tell. Here the acceleration vector is due to Earth's force. Earth's force divided by the mass of the body. So what is the Earth force at this point? More or less or equal? What is the gravitational force? Gravitational force is m into g. I told you no.
Yes, sir.
Then m changed from here to here. G is same everywhere now.
Yes, sir.
So the acceleration due to gravity will be same everywhere. Because the force is same, the mass is same near the surface of Earth. Near the surface of Earth, the mass is same, mass is not changing. The ball is same like that and it is same. And the force of Earth is also same.
Yes,
And therefore, why will the acceleration be different? It will be same. Hello?
Yes, sir.
See, I taught you yesterday, day for yesterday, and then still you are doing like this. So that means at home you are not doing any work. You should think what I did know, and I told you to watch the videos now. You are not doing it, and you better do it. If you want to crack IIT NEET, you better do what I say. Otherwise, don't repent later on. Okay? Time is ticking. As time is ticking, your knowledge and intelligence should keep improving. And that will improve only if you put the right effort. Otherwise, it will not improve. And don't think that ಈಗ ಹೇಳಪ್ಪ ಮುಂದೆ ಮಾಡ್ತೀವಿ no. ಇವತ್ತು ಮಾಡಿದ್ರೆ ಇವತ್ತು ನಾಳೆ ಇನ್ನೂ ಒಂದು ಮಾಡೋದಿರ್ತದೆ ನಾಳೆ ಇನ್ನೂ ಒಂದು ಮಾಡೋದಿರ್ತದೆ. So don't postpone, right? So the acceleration vector here will be same, like this, same magnitude, same direction. Now here the body momentarily stops. Hello.
Yes, sir.
Should I show the acceleration vector there?
Yes.
Yes. This boy is telling confidently yes. That boy is also telling yes. Why?
Sir, because gravitational force.
Because there is force. Whether the body is moving or not, now you are sitting here. Is there any gravitational force on you?
Yes, sir.
Gravitation force is always pulling. Because Earth is there, you are not actually moving. Otherwise, you would have been moving. Understood?
Yes,
So the
sir.
Earth is doing its job. So force is there, right? And divided mass will give you acceleration. Consequent to that, okay, whether the body will really move, that depends upon the constraints. Now your so therefore the acceleration vector will be everywhere.
Yes.
But well, you have to see the consequence. So this body you will still show the acceleration vector here. Got it? Now if you have a question here, you can ask. Okay. Now you see there is acceleration vector here. Okay. The body is at rest. The body is at rest, but still there is acceleration. Why? Because there is force action. So this is something that all of you should clearly understand. Right? So force acts as a consequence of force. If you divide force by mass, then you will get the acceleration vector. Now, if there are no constraints, then the velocity will change. Then the velocity will change. Otherwise, it will not change. Here, for this body which is here, is there any constraint? And here are body. So it will definitely change the velocity. So what happens because of this acceleration vector? The body which was going up will immediately start going down. There is change of velocity. Hello?
Yes, sir.
Do you appreciate the change of velocity?
Yes, sir.
So just before this, the body was going up. Now, after this, the body started going down. There is change of velocity vector, and that is the acceleration. Got it now?
Yes, sir.
So the acceleration vector is in blue lines, having same magnitude and direction when the body is going down. Now the body starts going down. So again the body will come to this point.
Yes,
Should
sir.
I show the acceleration vector here? When the body is coming down? Yes,
sir.
why? There is force acting. And what should be the acceleration vector?
Sir,
Same now.
Yes, sir.
And here?
Yes, sir.
Understood?
Yes, sir.
All of you?
Yes, sir.
So this is how you know the diagram works. This is how the diagram works. Is that clear? You have any question to ask? To ask. I will answer. You have any question?
No, sir.
Now you should tell me. Okay. So here that is P3. Hello. The instant of time is T3, and the body is neither going up nor coming up. It has stopped at that point. Correct now? It has stopped at that. Momentarily stopped at that point. And then the body starts descending. Again the body is in the same position. And now what is the instant of time when it is coming down?
T4.
T4. And the body is coming down. And here T5. And the body is coming down. Got it?
Yes, sir.
Now, what is the velocity vector here? Go, give me the with the abbreviation you have written now, V of something. Tell me. Louder. Yes, V T1. Munda. What is V T1? Speed at time T. And it is in what direction?
X cap.
So now you have to define the direction. If you say this direction is x plus x, and this direction you should say it is minus x. See, x and the sumna helbidabarda. You should define. See, you came to this earth. Your parents gave a name to you. Your name is now you are defined. You are on the earth in this name. Like that, if you are bringing something here, you should give the name of that. Understood?
Yes,
So you should say this is x plus x direction, this is minus x. Now, what should I write here? What is the velocity? This green one. VT1? Right. And here? VT2 x cap. Right. And here? So it is 0 bar. Got it?
Yes, sir.
So it has stopped. Understood?
Yes, sir.
Now it is coming down. So for that I am using this brown color velocity vector. So what is the velocity vector here?
VT4 minus
Yes, VT4.
Minus
Excellent. Minus x. And here VT5 minus x. Got it?
Yes, sir.
Now see the acceleration due to gravity, we use the symbol g bar. Acceleration due to gravity, you use the symbol g bar. Now, so this blue color one is acceleration due to gravity. Now tell me the vector form of it.
Sir, sir, which answer this?
And this one, blue color. This is the acceleration vector.
Sir, AT1 minus x.
AT1 minus x cap. What is your Anybody else with some other answer? You tell your heart. See, you tell whatever you feel is right. If you are wrong, I will correct you. I will teach you. But if you keep it within yourself, you will not learn. You will become buffoons. Yes, Mr. Aryan.
Sir, GT1 X cap.
So he says GT1 X cap. GT1 X cap will go.
Yes.
हाँ
Minus X cap.
मतलब GT1 minus X cap. Right? Hello?
Yes, sir.
Yes, sir.
Understood now? He is right. But not completely right, but still, okay. Benefit of doubt and give. Okay. So here, this one. What should I write here? Hello?
Sir,
T2 minus X cap.
G
T2 minus X cap.
minus X. Okay? And the body is going up. Correct? Here, what should I write?
Sir, GT3
GT2
minus
minus X cap.
GT3
acceleration
minus X cap. Got it?
Yes, sir.
Acceleration vector. When the body is coming down, what should I do for the acceleration vector?
Sir, GT4 minus.
GT4 minus X cap I should write.
Sir, that.
So here I should write GT4 minus X cap. Okay. So I will also once again write this as GT4 minus X cap.
Yes, sir.
Yes, sir.
And so you will tell me to write here GT5 minus X cap. Correct? Hello?
Yes, sir.
Now tell me the relation between GT1 X cap. Tell me the relation between GT1 X cap, GT5 X cap, GT2, this one, this one. What is the relation between all these acceleration vectors you have written?
Sir, their magnitude and the direction are same.
They are same, no?
Yes, sir.
Very good. See, Vijay has completely understood. See, his tone, his texture of his voice, there is full of confidence. And quickly he told. So, the acceleration vector is same. Whether it is time t1 or t2 or t3, it is same, both in magnitude and direction.
Yes.
So, therefore, gt1 minus x cap is equal to gt5 x cap is equal to gt4 x cap. So, acceleration vector is same. Got it?
Yes,
Hello?
sir.
Now, quickly answer. What is the relation between, see here, what is the relation between Vt1 x cap and Vt5 x cap, T5 minus x cap? What is the relation between these two vectors?
Their magnitude are same, sir, and direction are.
Excellent. Their magnitudes are same, direction is different. Look at the diagram there itself. He has completely understood vectors. Very comfortable. Okay? Understood?
Yes,
So
sir.
this is how you see your narration should be. And this is how you have, now you see, if a body is, if you're traveling, then you should simply write it as a point object and show the relevant vectors. See, the vectors are telling both in magnitude and direction. Understood? Because both are important. Without telling one, the other, if you tell only magnitude, no use. If you tell only direction, no use. And you should tell both and appropriately. See, I have shown the direction of the velocity vectors and I have shown the length of the velocity vectors. They are all meaning. See, this length and this length are same. This green one and brown one. That means the magnitudes are same, etc., etc. So, when I tell you now, when I throw something or when I tell you look at that body, it is in motion, then you should capture that motion in your mind's eye. See, now you captured the ping pong ball when it left the bat. You captured it and then, you captured the motion of the ball and you represent it on the piece of paper. And this is called scientific representation. If you simply say the ball will go up, come down, it makes a tuku sound. That is good for 5th standard, 6th standard students. Correct. For 6th standard, 6th standard, that is what is the observation you do. Now, having learned better, you should be able to answer it like this. Is it clear?
Yes, sir.
You have any question to ask, you ask. I will be more than happy to help you. Anything you want to ask here? Good? How many forces are acting on this body?
Sir, one.
Louder.
One.
Only one force. What is that force?
Gravitational force.
What is gravitational force? In sweet answer. What is gravitational force? You remember how I taught you gravitational force? What diagram I had drawn? If you remember like that, then you'll see, now all of you put your hands up. That is the art of learning science. See, you should not start searching the sentence in your head. If you start searching sentence in your head, you will go to docs. See, now your science book has got how many pages, total number of pages in the science book? 256.
180.
180 pages. 180 pages? 254. He has got 254, 180, right. So, say now, the NCERT textbook has got 254 pages. But original book, now it is reduced. The original book had got 280 pages. Now you have got 154 pages. Correct? Hello. So original book had got 280 pages. This contains what? Physics, chemistry, biology. Now when you come to PUC first year, right? You will have 2 volumes for physics, each having 250 pages. To approximately 250. So 500 pages physics. Volume 1, Volume 2. 500 pages chemistry, Volume 1, Volume 2. 500 pages biology, Volume 1, Volume 2. 1500 pages. Plus numerical problems. So if you add numerical problems, it will come to 800 pages. 800. And this will be 600 pages. So 1600 plus 600 will be 2200. So totally 2200 pages is the total syllabus. Now, the time for PUC first year is the same as what time you have got. You go to school for 7 hours, there also you will go to the 11th standard for 7 hours. Whatever timetable you have got now, same timetable you use. Only thing is, instead of history, geography classes, you will be having physics, chemistry. The timetable will contain physics, chemistry, mathematics, biology, plus 2 languages. That will be the total 6 subjects you will study. And the time is same 7 hours. But the number of pages you have to study is 22. So, what I am trying to tell you students, your learning speed now should be 10 times by the time you come to first year. Now your learning speed and teaching speed is so less. Your teacher has all the time in the world to teach 280 pages. Now the teacher will have same time, but he has to push 2200 pages in your head, and you should be able to absorb. Those students who absorb will triumph. Those students who cannot absorb will go to dogs. So therefore, day by day your learning capacity should increase. You should make a timetable for that. Today I have learned 20 pages. Tomorrow I should be able to learn 25 pages. So your speed should increase. So that is what I say, matured students. Those students who understood what I told today, you mark my words, you have good chance of cracking the competitive exam. Those students who did not understand what I said and who do not do what I said, then don't blame your parents, don't blame your school, don't blame your country. You are responsible. That is the secret of success. Your day-to-day mehnat will bring you to the top. I know many students who are extremely brilliant, but if they don't put the effort that I have put, that is, they have to improve their learning capacity, then even though they are brilliant, they will not do. But on the other hand, at this stage, there is a student who is not so brilliant, but who keeps doing what I tell. Then, trust me, on the D-Day, that student who is not brilliant will try. And that student who is brilliant and doesn't put the efforts like this, he will go to dogs. Okay, this is the history, statistics. So, therefore now, if you learn vectors like this and if you are able to do it, you will be successful. Start doing it. And this is the best way to learn. Right? Hello?
Yes,
Now, you see, ready? Okay. Now, you see a body. What will you do? What will you do? Yes, you just mark your point. And when I say it is a body, you will mark your point and simply write mass is m. Right? This is how you will visualize. It is in motion. Then what will you do? Loud. You draw it. So you will draw a velocity vector. Correct? Hello.
Yes,
Right. So draw a velocity. Right? You have drawn a velocity. Then what will you do? Yes, you name the velocity. Beautiful answer. Noda? Hinge helbitre nan philosophy shuru madina. So you don't want my philosophy, you better answer properly. So you name the velocity vector. How will you give the name to it first?
Sir,
B. Louder. X cap. So before that, what you should do? You should draw on the paper that this direction is plus x cap, this direction is minus. You should do this.
Yes, sir.
So you draw this. Hello.
Yes, sir.
Then a force acts on this body. If I tell you, listen.
Yes, sir.
if I tell you a force acts on this body, right? What will you do? What will you do?
Sir, in which direction?
You will see my face. You will not do anything. You will see my face because I didn't complete. Understood? So you should not assume. Okay. Now if I tell you a force acts on the body, you are looking at my face. Why are you looking at my face? Sir, you please. Sir, you should tell you should not tell negative to your teacher. Sir, you didn't give. Understood? You see manners. When you grow, the bosses, your teachers, your professors will be observing you. So they will observe the words that you are telling. So they will be observing you. So you should not use negative words. You should say, sir, please let us know what is the magnitude and direction. You should not say you didn't give. Sir, please tell what is the magnitude and direction. Understood?
Yes, sir.
That is how you should convert. Now learn all these things.
Yes, sir.
See, I have got my degree. I have got my degree from world's 17th best university in the world, Indian Institute of Science. The best university in India. Okay? And there they have trained me with all these things. I am giving you the training. Government of India invested money on me to make me a teacher. Now I am giving it back to the society. If you observe it, it is this. So you ask me what is the magnitude and direction. So I will tell you the magnitude is F1, okay, and the direction is x cap, right? So what will you what is the name you will give to the force vector?
Sir, F1.
F1 T1 x cap. Excellent, students. So you will ask me to draw a velocity vector, force vector F1 T1 x cap, correct?
Yes, sir.
Good, excellent. So I will now draw the force vector here, correct? Right? Hello?
Yes, sir. Yes, sir.
Alright. So I will draw the force vector. Right? And what is the name you told me?
F1 T1 x cap.
Yes, F1 T1 x cap. Right? What does F1 T1 x cap mean?
The force
acts on the body.
Body at time T1 in positive x cap. F1 T1 represents what?
The force.
F1 T1 represents what? F1 T1 represents what? Yes, magnitude of force, strength of force. F1 T1, see, the magnitude of F1 T1 can be applied at any point. Understand? Now you see, if I say apply force on my body, so what will you do? So you will ask where to apply and how much and in what direction. ಈಗ ಸಪೋಸಿಂಗ್ ನಂಗೆ ತಲೆನೋವು ಆಗಕತ್ತೈತಿ ಅಂತ ಹೋದಿ ಅಂತ ತಿಳ್ಕೊ. ನಿಮ್ಮ ಅವನ ಹತ್ರ ನಂಗೆ ತಲೆನೋವು ಆಗತ್ತೆ. ನಿಮ್ಮ ಅವ್ವ ಏನು ಮಾಡಬೇಕು? ನಿನ್ನ ತಲೆ ಈಚಿಕ್ಬೇಕು, ಹೌದಿಲ್ಲ? ಕುದ್ಕಿ ಈಚ್ಕಿತ. ಸೊ ಯು ಟೆಲ್ ತಲೆನೋವು ಆದ್ರೆ ತಲೆ ಈಚಿಕ್ತಾರೆ, ಹೊಟ್ಟೆ ನೋವಾದ್ರೆ ಹೊಟ್ಟೆ ಈಚಿಕ್ತಾರೆ, ಕಾಲು ನೋವಾದ್ರೆ ಕಾಲು ಈಚಿಕ್ತಾರೆ, ಹೌದಿಲ್ಲ? ಸೊ ಯು ಆರ್ ಟೆಲಿಂಗ್ ದಮ್ ವಾಟ್ ಈಸ್ ಯುವರ್ ಪ್ರಾಬ್ಲಮ್. Now if it is tali, the person who your mother will apply more force because tali has got this one. She will apply more force in the right direction. But same thing now. What you know, she will not apply the same force. She will apply less force. And you should know. So she will decide how much should be the magnitude and in what direction at what point. You got it now? See, that is what, and what your mother is going to do. What she is what I am going to represent from the book. Right? Got it? So I am now giving you the force and this. Now I will ask you the next. Then what will you do after I tell you these two things? What will you do? No. See, I have told you these two things. So I told you force acts and this acts. Now if I ask you what happens, then yes, in this case only speed will increase. But what are the relevant vectors you will draw? What are the vectors you will draw? Hello? This vector Indian vector acceleration vector. Got it now?
Yes, sir.
Got it now, all of you? You draw the acceleration vector. So how should I draw the acceleration vector? First, how should I draw the acceleration vector? So I should draw the acceleration vector.
Yes, sir.
How should I draw?
Sir, in direction of force.
In the direction of force or in direction of velocity. Both are in the same direction.
Yes, sir.
So I will show the acceleration. Got it? So I am showing the acceleration. Correct? Hello?
Yes, sir.
So this is the acceleration vector. So what is the name I should give to this?
Sir, AT1
Yes, I'll write here AT1 X cap. Correct? Hello?
Yes, sir.
Now, there are some things here that you see. What are the things? You see F1, you see M, you see V, you see A. Right? Now, there is F1, there is M, and there is A. These are three physical variables. Are they related?
Yes.
Yes, tell me the relation.
Sir, by dividing by force.
Tell me the relation. Correct, you are telling correctly, but tell the relation. Relation in terms of equation you should do.
Sir, A.
See, because I am asking you what is the relation, that means I am asking you mathematical model. Right, tell.
Sir, A is equal to.
No, you write completely. AT1
X cap.
X cap, very good, is equal to
F1
T1 X cap.
divided by
Brilliant students. You have really made me proud today. See, this much knowledge you have got. So understood now? So this is the whole thing that you have done. Okay? This is at time T1. This is exactly at time T1. Okay? Now, this is exactly at time T1. Got it? Now, at the time T2, right? At the time T2. Now, listen carefully. Listen carefully, think and answer. At the time T2, I have to again draw the what happens. At time T2, what happens? If I ask you. At time T2, what happens? I am asking you. Okay? Now tell me, at time T2, what happens? Tell me, at time T2, what happens? Think and tell me.
force in a
Very good, brilliant. That is what is the hallmark. He asked the right question. Is force still acting or no? Brilliant. That shows you have understood. Very good. So it all depends upon whether the force is acting or not. Great, Vijay. So he is asking, what is the thing, sir? Is the force still acting or not? Got it?
Yes.
Brilliant. Brilliant. Brilliant, student. So at time T2, if I tell the force is still acting, then what will you do?
Sir, speed. Sir, velocity will increase.
Now what will you do? Just scientifically, what will you do? Scientifically, see what you did here is scientifically you did. Now what will you do scientifically at time T2? You will draw all these vectors. You will draw all these vectors. Got it?
Yes, sir.
Okay. So you will draw all these vectors. Okay. So you will draw all these vectors. Right? Right. So at time T2, what will you do? Right? So you will do everything that you did now. Right? You will do everything that you did here. Okay? You will do everything that you did here. Right? Okay. Please understand this. So, you will once again draw all these vectors. Hello?
Yes,
So, I told the same force will continue to act. I told the same force will continue to act till time T2. So, what will you do now? You will again do the same thing, but now you have to give appropriate names. Hello?
Yes, sir.
You will give appropriate names. So, now start giving the names first. So, you see the three vectors. The same three vectors will be there.
Yes,
Now start giving me the names. You saw there. I had used blue color for velocity. Then I had used pink color for acceleration. Green color for force. So I told the same force vector will act at time T2. This is at time T1. Now this is at time T2. So what is the name I should give to this?
Sir,
So I will have to give the name F1, F1, T2, X. Right. Now I told same force is acting. So what is the relation between this vector and this vector?
Sir, the
Magnitude and direction both are same. So they are equal vectors.
Yes, sir.
That is what you should use. You should say, sir, F1 T2 x cap and F1 T1 x cap are equal vectors. Why they are equal? Magnitude is also same, direction is also same. Excellent. Very good. Now, what happens to the acceleration vector? What is the acceleration vector?
Same.
Same, tell me.
Same.
Hello, louder.
Same.
See, you told same, but you didn't say so confidently. Okay? Yes. Now you can write here. Now, sorry, here you have written A-T1. So here also you will write here A-T2 x. Now what is the relation between these two?
Sir, they are both equal.
Why they are equal?
Because their magnitude and direction.
Why their magnitudes are same?
Sir, because force
Force is same, mass is same. Therefore, right. Very good. So what about this velocity vector?
Sir, V
So it is now Vt2 x cap. Now think and tell. Now what is the relation between Vt2 x cap and Vt1 x cap? What is the relation? He is answering. See, you are all not answering. Only 3 students are answering. Okay, think, others think. What is the relation? What is the relation andre ee situation ಏನು ಆಗ್ತದೆ? ಇದು forcing act ಆಗಿ force T1 ಆಗಿ act ಆಗುತ್ತೆ. It will continue till time T2. So as a consequence, what will happen to the body? Here.
So the speed will remain same and the direction
Speed will remain same.
So as Vt1 x cap and Vt2 x cap, both will be same.
Same. Why? You are not. See, you are applying.
Sir, it was same
See,
force.
you are applying force. No.
Yes, sir.
So, if to your body, to your friend who is on the cycle, who is moving, if you push the cycle, what will happen?
Sir, the speed will increase.
Then what is that you are saying here? The same situation, no?
Yes, sir.
This is the same situation, no? Now here this mass m is the mass of your friend on the bicycle, and you see your friend at time t1 going with some speed, and then you start pushing your friend with force f1t, and you continue to apply that same force till time t2. So what happens to your friend?
So the speed will increase.
Why did you not say that? Isn't it?
Yes.
Now what is the relation between Vt2 x cap and Vt1 x cap?
So the directions are same, sir.
Good.
But the magnitude, the speed is more in Vt2 x cap.
That's it. Correct, no? So how will you say, how will you tell this mathematically, that speed is more? Mathematically, how will you tell? You said this speed is more than that. So what is the magnitude of this vector?
So
V is the, what is the, see this has got magnitude and direction. So what part is magnitude, what part is direction? See, this totally is a vector, isn't it? This totally is a vector.
yes, sir.
In this, there are two parts. One is magnitude, one is direction. What part is magnitude?
So magnitude part is V and x cap is the direction.
Then what is T2?
So instant of time.
So Vt2 means speed at time T2. See, Vt2 means speed at time T2. Correct?
Yes, sir.
So Vt1 means speed at time T2. Correct? And this thing is the speed. Thank you. And x cap means the speed in that direction. See, you are shouting in the car, speed in this direction. So what is the speed? When you saw the speedometer, you saw the speedometer. When did you speed the speedometer? At time t2. At that time, what is the speed? Vt2. Correct?
Yes, sir.
Vt2 means speed at time t2. Correct? That's how it is. And it was in x direction. Right? Now you said under this circumstance, the speed of the particle will be more at time t2 than t1. How will you write it mathematically? 2, 3 students. What about you do? Speed at time t2 is more than speed at time t1. What is the mathematical notation? Yes.
Sir, the velocity vector length should be more.
No. Velocity length vector is more. That is done in the diagram. In the diagram I have done that. Okay. For your sake I will do it. Okay. For your sake I will do it. Happy? Yes. Velocity vector is more. Okay, done. But mathematically, what should I write? How should, now I have told this velocity vector is Vt2 xk. This velocity is Vt1 xk. What is the relation between these two? How should I relate it? You told me the speed is more. So what is speed? Mathematically, what is speed? Just now I told, no man, mathematically what is speed? Vt2. The speed at time t2 is represented by Vt2. The speed at time t1 is represented by Vt1. Got it now?
Yes,
now you know that speed is more at time t2 than speed 1. So what is the mathematical notation I should use? Okay, so here.
So V1 D2 extra. So V1 D2.
What is the relation I told? You told this is more than this. Yeah.
The relations. Sir, the magnitude are different, sir, and direction is same.
I told what is the relation. Okay.
Sir, VT1, sir, ಆಮೇಲೆ greater than.
Very good. That's it. So you will write here V. So you will write here which is greater? Vt2 is greater than Vt1. Correct now?
Yes, sir.
This means the speed of at time t2 is more than that. Got it?
Yes, sir.
Simple no? See, you also knew this answer now. Why you didn't tell? See, tomorrow in examination, if you are hesitating, the time will go. So you are supposed to answer in CET 180 questions in 180 minutes. So if you don't develop that confidence now, you know the answer, but in 180 minutes you will answer 90 and come out. Somebody will answer 160. He will get better rank. Then you cannot sit and cry. Okay, then you have to cry. What else can you do? So tell. See, that time you told one half answer correct. I corrected it. That's how you will learn. If you don't tell, you will not learn. So this is the notation that you use to say that this is more than this. Right? Got it?
Yes, sir.
I taught you one more notation. What is that notation? Instead of writing all this, I can write this is equal to F1. Hello?
Yes, sir.
And I can write this is equal to V1. Now going by the same notation, what should I do here for this?
V2.
What should I write here?
Sir, F1 was.
You first write F2 bar if you want to write. But if you are a brilliant boy, then you can directly write this F1. Because I told you the same.
Yes, sir.
Then what should I write for this acceleration? A1 x cap. A1. Got it? So what should I write here? Good. See, you are learning fast. Excellent. Today is a wonderful day. So you are also able. Right. What should I write here? Loud. V2. Got it?
Yes, sir.
Okay. Now I want to say how will you relate V2 and V1? How will you relate V2 bar and V1 bar? How will you relate? Think and tell. What notation will you use? I taught you. You wrote the examination also with that new notation.
Sir, modulus.
No, hint kondu helagata now. Modulus. So here you will say now modulus. Here you will write modulus of V2 bar. Modulus of V2 bar means what? Speed of V2. Speed at time t is greater than modulus of V1. But
Yes, sir.
that means speed is more. So if they have given vector in this form, if you define vector in this form, then use this notation. If you have written vector in this form, then use this notation. You have options. So in some numericals, you have to use this option. Some numericals, you have to use that option. Is that clear?
Yes, sir.
Understood?
Yes, sir.
Now all of you, if you start, if you think properly and fairly, you should think scientifically and give the answer scientifically. Don't bother if it is right and wrong. Too much you should not bother. But you should not give some haphazard, something unconnected answer you should not give. You should based on concepts and theory. You give. If it is wrong, I will correct. See, the teacher's job is to motivate the children to learn. And once I motivate, you should take that motivation and learn. And then when I ask you question, whatever you have learned, you should tell. Teacher's job is to correct your mistake. Got it? So when I ask you a question, you will give the answer. If it is wrong, I will correct. Correct? If it is right, what will I do? If your answer is correct, what will I do? What will a good teacher do? If the answer is correct, what will the teacher do?
Appreciate.
No.
Encourage.
Loud.
Encourage.
No.
Sir, very good.
Huh?
Very good.
No. This is all I am telling in 8th standard. Now when you come to 9th standard, 10th standard, I will not waste my time telling you up very good, very bad. No, because I will be wasting your time. If I appreciate you, that much time is wasted. Instead of that, see, because every time I say very good, few seconds are gone. Say every time in this class, 10 answers you, 10 times I appreciate. 10 seconds into 10, 100 seconds I root plus class. Understood? So in one class I use 100 seconds. In 10 classes I will use 1000 seconds. In 100 class I will use 10,000 seconds. In that 10,000 seconds, how many things I could have taught you? How many numericals I could have taught you? Correct? So that is how IIT is done. So a good teacher will use the time properly. A good student will make sure that the time is used properly. So if you give me the right answer, correct answer, what will I do? I will teach you more. I will teach you better. Now you see, you gave me these answers fatafat. You gave this answer, this answer, this answer. How many things you learned? Then I took you to the next higher level. If you had not told that, I would be stuck with this only. You got my students?
Yes.
So it is you are primarily responsible to make the classroom a learning classroom. It is your job. It is your time. It is your life. I don't have to write exam. You have to write. You want to become doctors, engineers and scientists. I have finished my thing in this life. I don't have to do anything. I have nothing to gain. I have only thing got to give you knowledge. So you learn more. You learn this, I will teach you higher. Got it? So now, really whatever I have given you I have told all this, you think as soon as you go home. And especially before going to bed, what all I have told you think. And next day morning when you get up, okay, sir told all this, I will implement it today. See today Vijay, fatafat he gave the answer. Fatafat. And I wish everybody gives the answer. So he is slowly improving. He was not the best in this class. But today he is the best in this class. So it is his D-Day. So someday you might be best, someday you will someday. Correct? So let the D-Day come for all of you. And let the D-Day come for all of you all this simultaneously. Because when I asked you distance, all of you told the definition of distance together. Isn't it? So like that, you should tell all this. Clear? And go through my videos quite often and try to learn. Okay? Yes.